Welcome to the JTAG booth here at Productronica. Delighted to be joined by Peter van Eijnden. Nice to see you again, Peter.
Good to see you again, Trevor.
Okay.
Nice to see you.
So we're looking at a couple of things this week. One, celebration, of course, of the JTAG Live, which is now 10 years old. Tell us a bit about the history of that.
Okay. JTAG Live is, if you look traditionally at boundary scan, JTAG boundary scan, then it was originally developed as a tool or a method to test printed circuit boards in manufacturing, because in the middle of the 80s we as the industry saw that with surface mount technology we are no longer able to access the pins as you used to have for structural testing. Right. So in order to cover that problem or to solve that problem, the industry came up with a solution called boundary scan, JTAG boundary scan. So initially all the tools focused at production tests, which is logical because that's where it came from. Over time, of course, you then see that it's used in production, and then the design engineers step by step get problems with the surface mount as well, because you see the BGAs coming. And then they need solutions where they can no longer use their standard probing capabilities, using the multimeters and all the other equipment, but instead need to have other tools. So that's when we developed the JTAG Live as a tool for the design engineers, as well as service repair technicians later on, to be able to access single lines on their board to just check out, like they did with the multimeter traditionally, probe out, buzz out a connection. Is it there or is it an error in my design? And now using boundary scan, they can also probe out the connection between two boundary scan pins on the board easily, without having to set up everything beforehand. They can just, exactly like they want to do in design, is you have an instrument, you connect, and you measure, and then see the results. So that's what you accomplish with the bus tool, for example, in JTAG Live as well. We also have another tool there called Clip, and if you think of the name Clip, it refers to the old clip that you used to have with traditional instruments where we clipped over a chip with a logic analyzer, for example, and then you could measure all the signals. Now with boundary scan you can do the same. You have a boundary scan device, another boundary scan device, a non-boundary scan device in between, so you drive all the inputs, you observe all the outputs, and it's like having a clip on the chip. So that's the idea behind it. So it's tools for design engineers, very easy to set up and measure immediately, while a test engineer, so the other product line, is much more on, okay, I have to prepare the tests to make sure that I cover all the possible errors that can occur. Right. Okay, so then you have fault coverage and these sort of things, which for the design engineer are not so relevant, because he has other problems to solve. Yeah, exactly.
So JTAG Live is now 10 years old and going strong, I'm assuming.
Yes.
Good. So, new products you've got on the booth this week is ProVision.
Correct. Yeah.
What is ProVision?
ProVision is the development environment for the test engineers in manufacturing, so that they can generate tests automatically with the maximum possible coverage for fault coverage that they can achieve. Okay. So it's a tool where you read the data from the board you need to test, and then it has a large library of more than 250,000 device types that are covered in the library for the non-boundary scan devices. So the tool analyzes the board, recognizes the non-boundary scan devices, knows the boundary scan devices, so it has a lot of information about the board, and from there can already automatically generate a number of tests. Right. And then the test engineer can look at the fault coverage of those tests. He can compare that with the testability of the board, which you can also determine using ProVision. So then he sees testability is this percentage, my coverage is this percentage, I still need to create a couple of tests. And the tool provides him, or the environment provides him all the tools to create those tests and analyze their coverage or addition of the coverage that he has for his board. And that coverage is important to improve the quality of what you're producing ultimately, because you want to, as a manufacturer, you want to be able to have the highest possible quality of your printed circuit boards, of course, that you manufacture. Highest coverage of the time. Yeah.
Is it able to cover any undeterminated devices?
No, it's everything that you can access via boundary scan can be tested. That does include the boundary scan devices and connections themselves. It also includes non-boundary scan devices, like for example memories, as long as I have somehow, via the boundary scan devices surrounding that memory device, access to those pins of the memory device. Okay. And the same is true for other types of non-boundary scan devices. Yeah.
So any other leaded components basically that you can get access to?
Yeah, exactly. And what is of course very important is that the test engineer can easily create those applications, so that the model library, the huge model library helps a lot. There's a lot of other things in the tool that makes it very easy to create applications, look at what you created, look at the data that you have, and analyze it, and from there go further with your development process.
Right. So how do you program it? I mean, how easy is that?
It is straightforward. You read the netlist of the printed circuit board. You can even start without a netlist. You can just connect to a good board and read the chain from it and start from there. But if you read the netlist, then the models, you take the model library, and the models are assigned by the tool automatically.
Okay.
And then if there are other pinouts, you can still modify it a little bit. But what you can do also is you can assign multiple models to a single device. For example, to a boundary scan device, you can assign a boundary scan model as well as a non-boundary scan model. It's functional model. In the applications, you can assign different models for the same device if needed. If you have a single device of a particular type, you can still assign to that type different models in different applications for the same device of the same type. Different instances. Assign different models, because a single device may in one particular configuration behave a little bit different from the other configuration. So then you have a different functional behavior.
You can use the same model, but just change the value.
That perspective. Yes, right, correct. Yeah.
Okay, good. So this is a new product.
No, ProVision is not necessarily new, but it's a new release.
New release of it. Okay.
Yeah.
Okay.
Yeah.
So this is the
Some
updated
new
version.
release. Yeah.
Okay, good.
Yeah. Lots of changes, lots of updates, lots of new functionality.
Okay.
How this goes, right?
Yeah. And so how do you sell this to engineers? Is this a subscription-driven thing, or is it they pay a single price for it? How does it work?
The engineers can buy it a single price, and then if they have maintenance, they get the models, because they are updated all the time. Additional models added. They can get new software releases. They get support, all these sort of things. Okay. That's one model. They can also buy it as a subscription. That would be another possibility. But normally it's bought as a single package in front, and then with maintenance added.
Okay. Great.
Yeah.
Well, congratulations on the update, Peter.
Thank you, Trevor.
Thank you for telling us about it today.
Thank you very much.